Let's make sure we're ready for the test on Unit 11. Here's the practice test. Same instructions as always. The thing that might be difficult about this is we're going to have all the different rules for working with exponents all mixed together. There's no specific order here, so we want to make sure that we're paying attention. So on the first one, it says 3 to the 11th times 3 to the 6th. They have the same base. Remember, the rule is if they have the same base and we're multiplying, we add the exponents together. So we get 3 to the 17th. If you want to think, okay, I need to have 3 and then do 11 plus 6, that's 17, that's totally okay. If you want to say, well, I've got 11 here and I've got 6 here, so that's 17 threes altogether. Either way, totally okay as long as you're getting this right. There really isn't a ton of work to show on these particular problems, but there will be later on. Let's take a look at this division problem right here. We've got 7 to the 4th on the top and 7 to the 15th on the bottom. If you wanted to do this one using the subtraction rule that we use with quotients, you do 7 to the 4. It's the first one, the top one, minus the second one. So we'd end up with 7 to the negative 11. And then we've got to change that negative exponent to a positive by putting it on the bottom, because remember, negative means reciprocal. So this would be the answer right here, but it's way quicker to just go through here and say, look, there are 4 on the top, there are 15 on the bottom. These 4 are going to cancel with 4 of those, so that means there's 11 left there. So this would be 1 over 7 to the 11th. Again, gigantic number right here. We're probably not going to type that into our calculator and figure out what it is. 1 over whatever 7 to the 11th is. Either way is fine. I kind of like this method a little bit better. In fact, I'm going to circle this right here just to make sure we're clear. I do think that that's a little bit better. Okay, let's take a look at the next one. This is where we've got 10 to the 4th raised to the 7th. This is a power raised to another power. If we do that, then we multiply the exponents. So this would be 4 times 7. That's going to be 28. Go ahead and circle that. Next one here, we've got 4n to the 5th, all in parentheses raised to the 3rd. That means the exponent applies to everything in parentheses. That means we've got 3 4s and we've got 3n to the 5th. If you want to write them out like this, if you want to write 4 raised to the 3rd and n to the 5th raised to the 3rd, totally okay. If you just want to think about these kind of, the exponent kind of distributes, if you want to think of it that way, this is going to be 4 to the 3rd, and this is going to be n to the, we multiply these together, so that's to the 15th. 4 to the 3rd, that's a number that you should recognize. That's 64, relatively small number, one of the perfect cubes. So we're going to write it like this. So there's our answer on that one. Let's take a look at the next one. Notice that it's similar but a little bit different. We've got parentheses around the negative 4n to the 2nd, and we're raising this to the 3rd. So when we apply it to each one of these, this means there are 3 negatives, 3 negative 4s. So 3 negatives makes the answer negative. 3 to the 3rd, again, is 64. And n squared raised to the 3rd, power to a power, we multiply those. So this would be n to the 6th. We're going to circle that. Done with that one. On to the next one. You'll notice that we've got a negative 2 on the top and a negative 12 on the bottom. We can kind of simplify the coefficients separately from the exponential expressions right here. First thing we want to notice is this is a negative divided by a negative. A negative divided by a negative is a positive. So I'm going to go ahead and cancel those off, make sure those are positive. 2 goes in here once, 2 goes in here 6 times, so we've got a 6 on the bottom. We've got x to the 4th on the top and x to the 4th on the bottom. That means these 4 are going to cancel with those 4. That means there are no x's left. So the only thing left here is a 6 on the bottom, but remember, there's always a 1 left of any division or multiplication problem, and we do have to write it there since we want to make sure everybody knows that the 6 is in the denominator. It's got to be in the bottom. Okay, taking a look and moving on here. Here's number 7. Got this big fat dot for multiplication. Let's take care of the coefficients. Negative 3 times 2 is negative 6. X squared times x to the 4th. If I've got 2 of them here and 4 of them here, I'd add those together and I get 6 altogether. Let's take care of the coefficients right here. Negative times a positive is a negative. If you do 18 times 7, if you grab your calculator, again, no problem doing a calculator. If you throw that in, you're going to get negative 126. Then let's take a look at these. We've got some T's and some U's. Remember, we want to write these in alphabetical order. So TUV. So we're going to do the T's first. I've got 10 here and 1 more right there. Remember, if it's not written, the exponent is a 1. So that means altogether we have 11. And then we've got 12 U's here and 4 U's here, so this would be u to the 16th. So we'll go ahead and circle. And moving on, we've got a negative times a negative, and notice how we don't even worry about what the numbers are until we need to. So a negative times a negative, this is going to be a positive. Okay, so I'm just going to turn those to positives. 11 times 15, if you want to throw that into your calculator, great. If you want to think, if this was 10 times 15, that would be 150. So 11 times 15 would be 15 more than 150, so that's going to be a 165. And then let's take a look at what we've got here. We've got H's and G's. Let's see, I always have to say the alphabet. G, H. So G is going to come first. So we've got 3 of them here and 8 of them here. So that's going to be G to the 11th. We've got 5 of the H's here and 12 of them here. So that's going to be H to the 17th. Circle that and move on. Notice on this one we've got this kind of ugly expression on the inside. We've got a couple coefficients. We do have all A's here, so that's kind of good. And then we've got a 15, but all of that is going to be raised to the second power. Generally, it's going to be simpler if we simplify what's inside the parentheses, then apply the exponent outside. So the first thing I'm going to do is notice that the 15 and the 3 will cancel. 3 goes in here once, 3 goes in here 5 times. We can take a look at the A's. There are 2 A's here and 4 A's there. So I can cancel 2 of these with 2 of those. That would leave 2 there. So here's what we've got. We've got a 2, we've got an A and another A. So that's going to be A to the 3rd. And then we've got 5 on the bottom, and then we're going to square that. Now if you wanted to, you could do this. And I'm going to go back here and erase that so we can kind of keep track here. We could multiply these together and we would get 6a to the 5th, and this was still 15a squared. That whole thing is going to be squared. And then if you simplify this, watch what happens here. 3 goes in here twice, 3 goes in here 5 times. These 2 are going to cancel with 2 of those, so we'll end up with 2a to the 3rd right here. We'll end up with a 5 in the denominator, and it's still squared there. Now we can apply the squaring from the outside the parentheses. So we're going to square each one of these. 2 squared is 4. A cubed squared is going to be a to the, remember, power to a power, we multiply these, so that's going to be to the 6th. And then 5 squared is going to be 25, and that right there is the answer. And you'll notice the similarities and the difference between 11 and 10. This one has a set of parentheses on the top and the bottom. This has one big set of parentheses. That's why we simplified this stuff inside. So we're going to go ahead and simplify the top by applying this exponent. So this is going to be 3 to the 3rd, x squared to the 3rd, and y to the 4th to the 3rd. So 3 to the 3rd is that common perfect cube, 27. X squared cubed is x to the 6th, power to a power we multiply, and this would be y to the 12th. In the denominator, we're going to square each one of these. So this is going to be 6 squared, so that's going to be 36. This is going to be power to a power, so that's going to be x to the 14th, x to the 14th right there, and then y to the 2nd. Now we can go through and simplify like we were doing before. So we can cancel, 9 goes in here 3 times, 9 goes in there 4 times. So this is going to be a 3 on the top, a 4 on the bottom. Let's take a look here. 6 x's on the top, 14 of them on the bottom. These 6 are going to cancel with 6 of these. There would be 8 left. So this is going to be x to the 8th. And over here we've got 12 y's on the top, 2 y's on the bottom. These 2 are going to cancel with 2 of those. That would leave 10 here. So this is going to be y to the 10th. All right, let's take a look at the next one. We do have a little bit of simplification to do here, so let's apply that exponent to each one of these. That's going to be 16. 4 squared is 16. M to the 5th to the 2nd, that's going to be m to the 10th. N squared to the 2nd, that's going to be n to the 4th. And then we're going to times that by 5, m to the 6th, n to the 3rd. Okay, so let's see what we've got here. We can multiply these numbers together. 16 times 5 is 80. Double check me on your calculator if you'd like. M to the 10th times m to the 6th. Add the exponents, or you can just think I've got 10 of them here and 6 of them here. So that's going to be 16 of them all together. 4 of them here, 3 of them there, so that's going to be 7 of them all together. And sliding down to keep moving through this. 45 and 9, there's nothing weird going on here, so we're just going to go ahead and simplify. This would be a 5, so we've got a 5 left on the top. 4 of them here, 5 of them here. 4 are going to cancel. There'd be an a left on the bottom. 9 b's here, 2 b's here. 2 of them are going to cancel. That would mean there's 7 left on the top, so b to the 7th. So 5b to the 7th over a. Next one, again, negative divided by negative. Take care of those signs first. Make sure you don't make a mistake on those. So I'm just going to cancel here. 4 goes in there twice, 4 goes in here 3 times, so we know we've got a 3 on the top and a 2 on the bottom. I do have room over here if I needed to, simplify a little bit more, but I know this is probably going to be my answer here. So 7 W's on the top, 10 of them on the bottom. Those are going to cancel. We'd be left with 3 on the denominator. Whoops, make sure that's a 3. And then we've got 5 V's on the top and 9 of them on the bottom. These 5 are going to cancel here. We'd be left with 4 of them, so that'd be V to the 4th, and we're done right there. Now, if it doesn't look perfect, if you want to move the 3 over so it's centered on the top, that's fine, but it really doesn't matter. Okay, let's take a look at this next one. We're going to apply this to every one of these. We've got this expression right here, all of it raised to the 3rd power, so there's 3 of everything. 3 negatives, answer is going to be negative. Then 9 times 9 times 9. Now, that is one that we had before. If you want to check on the calculator, it's 729. 729 is 9 cubed. And again, it's negative because there are 3 of those negatives. And then this would be x to the power to a power we're going to multiply, so that's going to be 24. Power to a power we're going to multiply, so that's going to be 21. Circle that, and we will keep plowing through this, see how quickly we can do it. Same thing here, we're applying this 6 to all of these, so that means there are 6 negatives. If there are 6 negatives, the answer is going to be positive. So for this one, I'm just going to quickly review. We could take this and say it's negative 2 to the 6th, x to the 7th to the 6th, y to the 3rd to the 6th. If you wanted to write all that work out, totally okay every single time, that would be great. 6 negatives would make a positive. If you'll remember, 2 to the 5th is 32. So that means 2 to the 6th. 2 to the 6th has got to be double that, so that's going to be 64. So this is a positive 64. Power to a power we multiply, so this is going to be to the 42nd power, and then this is going to be same type of thing, except for we're going to get 3 times 6 is 18. So we'll circle that. And again, this is a little longer than what you could expect to see on the test, but you will notice that on a couple of these next one, there's some cool tricks that we can use here. So take a look at this right here. We've got this ugly expression. If we wanted to go through and follow that general rule of 3x to the 5th, let's write that as z to the 7th, and we're going to raise everything to the 0 power, apply that to everything in here. Or we can just say this, hey, whatever this blob is inside here, whatever that number is, it's raised to the 0 power. So instantly we can just say that the answer is 1. No work required. If we wanted to say any number to 0 power equals 1, that would be awesome. Okay, let's take a look at the next one. Now this has an asterisk by it, and it's there for a reason. People get caught up in things. They look at something and they think, oh my gosh, this has got to be way more difficult than this. Here's the cool thing about this. We like plain old numbers. We like those constants and coefficients sitting out in front there, and we like things with positive exponents. The only thing that's wrong with this is that has a negative exponent. Now remember, the negative in the exponent means reciprocal, and the exponent only applies to what it's over, and what it's over has to be in parentheses if there's more than one factor. So on this right here, that does not have a set of parentheses. So this is literally 12 times r to the negative 3 times t to the 8th. So it only applies to the r. Now you don't have to write this out. You could simply say, look, we like the 12 where it is. We like the t to the 8th where it is. What we don't like is the negative exponent on the r. It means reciprocal, so we move that from top to bottom, and this is it. Don't make it more complicated than it has to be, and don't mistake something for being in the base of an exponential when it's not. If there's going to be more than one factor, then it's got to have parentheses on it. Okay, last couple on this page. The thing we need to do here is we need to write everything with the same base. Those are the properties and rules that we've been using up above. So these are not written with the same base, so we make them written with the same base. And this is why memorizing some of those perfect squares, perfect cubes, powers of 10 and all that sort of stuff come in handy. This is 3 to the 3rd raised to the 4th times 3 to the 6th. So we just need to rewrite this one right here. 27 is the same as 3 to the 3rd. Power to a power we multiply, so that's 3 to the 12th times 3 to the 6th. So altogether that's going to be 3 to the 18th. Way too big to figure out what number that is, so we're just going to leave it. Let's take a look here. These can both be written with powers of 6. Don't think 3 or 2 or anything weird like that. If you list them out, you'll see you can only write this with powers of 6. So this is going to be 6 to the 7th the denominator is going to be 6 squared to the 5th. Again, notice 6 squared is the same as 36. We haven't changed the bar. We haven't changed anything above the bar. It's still 6 to the 7th. We haven't changed the exponent of 5. All we did was put a set of parentheses and write 36 as 6 squared. So this is 6 to the 7th on the top, and this is 6 to the 10th on the bottom. These 7 are going to cancel with 7 of those, so we have 1 over 6 to the 3rd. That's it. If you wanted to, you could write 1 over 216. That's one of those perfect cubes. If you wanted to, you're totally welcome to, but I would take either answer there. And then this one on number 21. Same type of idea here. 49 and 7 can both be written as powers of 7. So this is 7 squared to the 6th times 7 to the 4th. So this would be 7 to the 12th once we do that power to a power times 7 to the 4th. So altogether, 12 of them here, 4 of them there. That's going to be 7 to the 16th. We'll circle answer and head off to the other side. Okay, on 22 through 24, we want to make sure that we pay attention to the instructions here. It just says write in scientific notation. So the decimal on this is the key to getting this right. We want to identify where that is. So again, we're writing this as m times 10 to some power. We're going to move this over 1, 2, 3, 4, 5 places. So we're going to do 2.45. We can only have one non-zero digit in front of the decimal, times 10 to some power. And that power is, if we moved it to the left, we made it smaller. We made this number smaller. So we need to make this exponent bigger by 5 decimal places. Or in other words, we're just going to make that an exponent of positive 5. Remember, big numbers are represented by positive exponents in scientific notation. So there we go. Next one, we've got this small number, and that should give us a hint of what's going on here. Now, I'm counting this by ones. If you want to do it by 2s or 3s or something like that, that's totally okay. So we've got 3.24 times 10 to some power. Again, we made this tiny number bigger, so we've got to make the exponent smaller. In other words, we're subtracting 1 for every place we move the decimal. So if you count that, that's 3 there and 6 there, so this is going to be a negative 6. Positive exponents represent big numbers, negative exponents represent small numbers. This next one is not in scientific notation yet, and you'll notice why. We need to move this over one place. So this is 1.445 times 10 to the, and remember, we made this smaller, so we need to make this bigger. This problem is on here for a reason, because everybody messes this up, so please don't mess it up on the test. When we made this smaller, we need to make this other one bigger. Oops, let me draw it over here. So bigger, bigger. And so by bigger, we mean add 1. So that's going to be 10 to the negative 3. So there is our answer on that one. Okay, so on to number 25 through 27. So let's write this in standard notation. This is in scientific notation right now, so this is going to represent a big number. If it's a positive number, we're going to move it that many decimal places to the right to make that a bigger number. So let's see, I'm going to move it in 3. So we're going to go 3 here, we'd need a 0, another 3, and then 1 more. So here's what we've got, 5, 6, 7, and then it looks like we've got 5 zeros. Okay, so we'll put some commas in there so it's easy to tell. So this is 56,700,000. Next one, it's a negative exponent, so that means we're going to move it 4 places to the left. So I'm going to go in 2s. So here, whoops, here's 2, and there's another 2. So we fill in with a 0 there. Again, if you want to count by ones, totally okay. So this is going to be 3 zeros and a 1, 4. Circle that. And this one, all we have to do is move this 1 decimal place to the right. So we're going to move it over here. So this is a funny way to write the number 32. Okay, this says perform each operation, leave your answer in scientific notation. So I'm going to pull this up, and here's what we do. I'm going to multiply these two numbers together. I'm going to do 6 times 2.7. So 6 times 2.7. So we hit enter, and we get 16.2. So 16.2. Let's figure out what the power of 10 is here. We've got negative 9 and 5, so we put those together, we get negative 4. Again, you want to make sure that it's in scientific notation, and it says leave your answer in scientific notation. So what we want to do here is we want to move this over 1. So this is going to be 1.62 times 10 to the, and remember, we made this smaller, so we need to make that bigger, so we're going to add 1. So this is going to be to the negative 3. So I'm going to go ahead and circle that. Next one, we'll do the 5.4 times the 1.8. Again, you've got access to a calculator, so please make sure you're using it to get these right. So we'll multiply those together. We get 9.72. And when we get something that has only one digit in front of the decimal, that's pretty cool because we know that it's already in scientific notation. So we've got -4 plus the 8, so that's going to be 4. So we'll go ahead and circle that. And the next one, we've got 1.9 times 8.9. And this is 16.91, so 16.91, we know that that answer is not going to be in scientific notation yet. Let's put these together. We get -14. We're going to move this over 1, so this is 1.691. We made this number smaller, so we make this bigger. We made it 1 decimal place smaller, so we make this 1 digit bigger. So we add 1, so we get 10 to the -13. Circle that. And now we've got some division ones. Again, we're going to leave these in scientific notation. Let's see what we've got here. If we do the 1.2 divided by 12, and again, some of these, especially with the division ones, gosh, if you can kind of think ahead just a little bit, you might be able to do this. So this is going to be 1.2 divided by 4. Shouldn't be any surprise that that's 3 because 12 divided by 4 is 3. So there's a 0.3 here. And then times 10 to the, we subtract the bottom from the top, or you could think of this as moving up to the top and becoming a 10 to the -3 and then adding them together. Either way is fine. We get this. We just want to make sure that when we're dividing, we always end up with the power of 10 in the numerator, never in the denominator. So we've got this right here, not quite in scientific notation because we have to move this over 1. So we're going to make this 1 decimal place bigger. So we're going to make this 1 decimal place or one exponent smaller. So this is going to be 10 to the 6th. If you wanted to write that as 3.0 times 10 to the 6th, totally okay. In fact, let me just write or 3.0 times 10 to the 6th, just so everybody knows that you could write it that way if you wanted to. Let's do this one here. 2.4 divided by 4. Pull the calculator up again for that one. 2.4 divided by 4. Gosh, if this were 24 divided by 4, I'm hoping everybody would know what it is. So you'll notice what we get here, 0.6. So this is 0.6 times 10 to the, and then again, if we move this up in the numerator, that would be 10 to the 3rd. So we have 9 of them all together. Or you could do 10 to the 6 minus -3. That's going to turn into a +3. We need to move this over 1 place. So this is going to be 6.0 times 10 to the, and remember, we made this bigger, so we're going to make that smaller. So we're going to subtract 1. That would be an 8. Okay, and let's see, 6.4 divided by 1.6. Gosh, I hope you know what that is. If this were 64 divided by 16, those are some pretty familiar numbers. So I'm going to do 6.4 divided by, let's see, hit divide, 1.6. And we end up with 4. The cool thing about that is we've got the number 4, so I'm just going to write 4.0, and then let's figure out what the exponent is. 10 to the 5th divided by 10 to the -5th. 2 ways to do this, 5 minus -5, or we could just write that on the top, so we add them together. So this is going to be a 10 to the 10th either way. So we'll circle that, we're done there. And then it says, of A, B, or C, which number is the biggest? So if we look at these numbers, we've got 9.9 times 10 to the -4, 1.1 times 10 to the 4th, and 5.5 times 10 to the 0. If we just looked at the decimal numbers, we'd think, oh, well, that one's got to be the biggest, and that one's in the middle, and that one's the smallest. Well, if we're looking for the biggest, remember, in scientific notation, big numbers are represented by positive exponents. That's 0 for an exponent, so this is just a weird way to write 5.5, because that would just be a 1. This is a negative exponent, so we'd move the exponent to the left, making that smaller. This is the biggest one. Explain how you know your answer is right. It's the only one with positive exponent. All right. So again, positive exponents are always going to be bigger than ones with negative exponents. Bigger that number is, bigger the exponent is, the bigger the overall number is. What is the difference between 3x squared y to the -4 and 3x squared y to the -4? Well, the big difference here is this is in parentheses. So we're going to say this. Parentheses means the -4 applies to all the stuff in parentheses. All right? The negative only applies to the y here. -4 only applies to the y. All right, so the -4 here in the exponent only applies to the y because that's all it's over. And here, because it's in parentheses, it applies to everything in parentheses. What does a negative exponent mean? It means reciprocal. It means we're going to take that exponential expression from top to bottom or bottom to top, kind of flip it over, if you will, to get that so it's positive. If you raise a number to the 0 power, what do you get? You get 1 every time. And then this last part here says complete the following. Now, you do not have to have all of these memorized, but the more of these you have memorized and can just recall, the quicker you're going to be at doing some of these problems. We've seen 3 to the third several times. It comes up all the time. We've seen lots of powers of 2. We've seen a few powers of these guys right here. I've got some perfect cubes on there, and even the powers of 10 would be good to memorize. So I'm going to run through here and put these down. So 2 to the first 2, 2 to the second, 2 squared is 4, 2 to the third is 8, 16, we're doubling every time, so 32, 64, 128, and 256. These numbers come up quite often. Come up a lot. If you like computer science, they come up quite often there too. So 3 to the first 3, so we're going to be multiplying by 3 every time. So this is 9, 27, this is 81, and then this is 243. 4 to the first is 4, 16, then 64. 5, 25, and 125, 6 and 36, 7 and 49. And just for the heck of it, what if we had 10 to the first, 10 to the second, 10 to the third, 10 to the fourth, 10 to the fifth, 10 to the sixth, 10 to the seventh, and so forth? Well, to write those down, they're very quick. Powers of 10 are awesome because this just tells us how many zeros we have. We have 1 0 here, 2 zeros here, 3 zeros here, 4 zeros here, 5 zeros here. I'm going to put a comma in there in the correct place. Let's see, 6 zeros here. So that's 1 million, and this would be 10 million if we had 7 zeros. Okay, now remember, you can always use your calculator to figure these out, but if you've got these memorized, it's just going to make you much quicker at recognizing them and more able to do the problems. All right, good luck on the assignment and good luck on the test. If you've got questions, please ask.